Today we'll learn about electricity. Visualize a different world where you couldn't turn on a light, a computer, or even use the electric kettle to make your favorite hot chocolate drink. We use electricity constantly in our daily lives. It is one of our most important types of energy and power that we use. Its uses range from small batteries that operate your remote control car to huge motors that power ships and trains.
Tricky baby, number frequency.
Yeah.
It's load shedding time now.
Okay.
Take the
And
electricity,
okay,
Nana.
I'm doing it now.
Sharp.
Inky Binky Bonky, who's not gonna have electricity tonight? Cape Town, how you?
Bring back the electricity.
Which one also has a load shedding tonight?
It's Devon by the Naidus and
Oh,
the
okay.
Cavenders.
Devin, I'm sorry.
Alright students, as you explained in the previous slide, we clearly explained and defined what load shedding is. I will be using our app PHET for a visual representation as to how load shedding works in South Africa. So here on our tools, we have our wire, we have our battery, we have our light bulb, and our switch. Our light bulbs will be representing our communities that will be building using these resources that we have. So now let us build our community together. Here is our light bulb that will be representing our communities as I have explained. Given that we have two types of circuits, I will be using a series circuit as it clearly shows how households will be able to share the electricity amongst themselves. As you all know that in parallel, they do not share the power source amongst them equally, but then they actually all will get the same amount. Now here's our second community. Now we just added our third one. And now we are going to add our switch, which will be like our main generator. As we all know that electricity needs a power source, our battery will be our main power source in this instance. And for our final community, the fifth one. as I have explained, this is a series circuit. We're using a series circuit as it will definitely define our load shedding, as they all share one power circuit and they'll be able to share the power amongst them equally. Now, for illustration purposes, I am going to set the voltage of our main power source, being our battery, on 100 volts. So that means in this case, since it's a series circuit, all the five light bulbs which represent our communities will be having 20 volts each, as they are 5, as that is 100 divided by 5, which is 20. Now let us put on our switch. Now I did say that this is on 100. As you can see, we can test what I just said in terms of the light bulbs sharing 20 each by using our voltage. As you can see, it demonstrates that it is 20 volts. Let us test another one. It is 20 volts. So that means all 5 of them will be 20 volts. So now a proper explanation as to how load shedding works. So in this case, as you can see, all 5 of our communities are shining bright. That means at the current moment, our main electricity provider, which is Eskom in this case, has enough resources to provide for all 5 households. As you can see, that's why they are all shining bright. So in this instance, Eskom can only provide electricity up to 100 volts, which is enough for all 5 households, right? So what causes load shedding now? The reason for load shedding is that Eskom can find itself running out of resources. That is coal in this instance. So when there is shortage of coal, that means electricity will be low that will be provided by Eskom. So in this case, since coal is low, Eskom can only provide up to 80 volts. Let us reduce this. We will see what will happen to the households. They will also be dimmer as we decrease the volts. As you can see, they are going lower. Now, as you can see, that means now Eskom can only provide us with 80 volts amongst the 5 households. And remember, at the beginning, we saw that each household needs 20 volts for it to be able to light brightly. So now let us tell what is our new voltage amongst the households, which are represented by the light bulbs. As we can see, now it's no longer 20 volts per household, but it is 16. The reason being, Eskom can only provide us with 80 volts, and each household needs 20 volts. So now this is where we implement load shedding. So what happens during load shedding? That means one community is going to have to be out without electricity for a certain amount of time for all households to be able to have the necessary volts, which is our electricity, which is 20 volts. So what do? We need to take out one household for them to be able to share the 20 volts again. So now this is how we're going to be implementing our load shedding. So in the meantime, we're going to take out one household. Now what happens to the households? They are shining brighter again, the way we saw them in the beginning. Let's test that theory again. Let us see if they are back to the 20 volts that we saw in the beginning. As we can see, now because there are 4 households sharing the 80 volts, they are now back to 20 volts. So that is how load shedding is implemented. So it is implemented on a time schedule. Usually, as it stands, there's a time schedule of 2 hours per household. So each community can be without electricity for 2 hours. So once one household gets its electricity back, then the next household will be out. Let us put this into demonstration. Now we are putting this household back. Since this one is back, and now you can see it's dimmer and it's back to 16 volts, that means the next community needs to be out of electricity. And there we have it. Let us test it again. As we can see, ladies and gentlemen, I hope this illustration was clear enough and you now have a clear understanding of how load shedding works. Thank you.